Dear students, in this lesson we are going to learn about the unit circle. I have a circle here. I put it on the Cartesian coordinates. This coordinate is x and this coordinate is y. The radius of the circle is 1. If the radius of the circle is 1, then can you tell me what this point is where the circle intersects with the x coordinate? It's going to be 1 to 0, right? X is 1, y is 0. How about this point where the circle intersects y? That is going to be where x is 0 and y is 1. And this point is where x is minus 1 and y is 0. And how about this point? That is where x is 0 and y is minus 1. So if you haven't seen this in your math classes yet, I can tell you that this is actually a graph of a function, and that function is x squared plus y squared is equal to 1. Okay? Any point on this circle satisfies this condition because that is the graph of this function actually. Alright, so in the last lesson we also saw that sine theta square plus cosine theta square is equal to 1. This equation looks very much like this one. Do you think it's possible that if I change sine theta with either x or y and also cosine theta with the other one, I'm going to get again a unit circle? The answer is yes. But here is the question: is x sine theta or is y sine theta? So how can I know that? Well, I have already these intersection points. This one, for example, 1 to 0 and 0 to 1. This is going to give me an idea about it. Okay? If I look at a right triangle where this is the theta and this is 90 degrees, and if the hypotenuse is 1 and the opposite side of theta is x, or let's give another name so that you don't get it confused with the Cartesian coordinates, so let's call it a. Okay, sine theta is going to be a divided by 1, right? So sine theta is a. What happens if theta gets bigger and bigger? By the way, we're not changing the hypotenuse, it's always 1, and it gets even bigger, right? You can see that a is getting bigger. The bigger theta value I have, the bigger a value I have. The bigger a value I have means sine is getting bigger. I can write it something like this: when theta goes up, sine goes up. Or better notation, sine theta goes up. So at this point y value is 0, and at this point y value is 1. When I have an angle here, let's call this angle theta, and when this theta gets bigger, the y value of that theta gets bigger, because y value is this, and x value is this one here. So you can appreciate that when theta gets bigger, then y value is going to get bigger, because when theta goes close to 0, then y value goes to 0. Actually, this kind of gives me the idea that if I want to locate sine and cosine to the Cartesian coordinates, y should be sine and x should be cosine, because the opposite is also true. Let's look at this example here. Again theta, and this time I call the adjacent side B, and this is 90 degrees. What can I say? This is the adjacent side. Cosine beta is equal to B divided by 1. So cosine theta is B. What happens to B when theta gets smaller? The smaller the theta gets, the bigger the B gets, because I'm not changing the hypotenuse. And the bigger the theta gets, then smaller the B gets. So that means when theta gets bigger, cosine theta gets smaller. Again, if I look at here, when the angle theta gets bigger here, let's say I'm going to have this one here, and be careful, these both lines here are the radius of the unit circle, right? So if theta gets bigger, what happened to x? Here it intersects with the x coordinate here, and the value of x gets smaller, just like we figured out what happens with the cosine. So basically I can say that I can replace x and y with sine and cosine, and eventually I'm going to get the unit circle. This is actually a very important consequence, because now I'm not limited with the right triangles, because in a right triangle theta must be bigger than 0 and smaller than 90 degrees. But in unit circle I don't have any limits. It could be any degrees. It could be 0 up until 360 degrees. And also another consequence of figuring out that sine theta square plus cosine theta square is equal to 1 is going to be a unit circle, is that now I'm going to have an idea of what happens when the theta is 0 and 90. Well, let's write it down together. Sine 0 degrees is equal to, don't forget sine is y, 0 degrees is equal to 0. Cosine 0 degrees, on the other hand, is equal to, what is that? Its x-axis is equal to 1. How about sine 90 degrees? That is going to be equal to 1. And how about cosine 90 degrees? Well, that is going to be 0. Now that I have this opportunity, I can also figure out the sine and cosine values of the angles that is bigger than 90 degrees, as well as those angles that I can call as negative angles, which is going to be pictured as the angles that I choose with the clockwise direction, right? Because these angles I choose, they start from the x-axis and they go counterclockwise direction, right? So this theta angle is, for example, goes from x-axis counterclockwise to this location. Now I'm going to have some interesting conclusions about that. For example, theta has its own sine and cosine values. Actually, you know what? I'd like to clean this chart so that we're going to have some space to work on. Okay, now I have a clean unit circle that I can work on. Let's have a look at this. I have the angle theta. If I go counterclockwise and choose the same angle here, again, this one is going to be minus theta. And when I look at the cosine value of theta, it is going to be equal to cosine value of minus theta. This is a very important conclusion. Basically, what I'm saying here is cosine minus theta is equal to cosine theta. But how about sine? For sine, the picture is different. This distance is going to be equal to this distance, whatever this is. Let's say this is going to be c. This is going to be minus c, right? For the trigonometric function sine, I can say that sine minus theta is equal to minus sine theta. These are very important conclusions that we can figure out from the unit circle. The radius of this circle is 1, which is at the same time the hypotenuse of this triangle here, where I chose theta to be one of the angles of it. Can I get more and more interesting conclusions from unit circle? Yes, I can. Look what happened here. This is the angle theta, right? What is this one here? If this angle is also theta, then the total angle for this one is going to be 180 minus theta. I think this is again getting too complicated here. Let me clean the chart again one more time. Okay, let me have the angle theta here, and let's get this angle here. If this part is theta, then the measure of that angle is going to be this one here, 180 minus theta. But can you see that the sine values of theta and 180 minus theta is equal? Then sine theta is equal to sine 180 minus theta. But at the same time, if you look at the cosine values of theta and 180 minus theta, you're going to see that their absolute values are equal, which means if this is, let's say, d, this is going to be minus d. I'm just giving random names here. It doesn't matter. You can name them anything. A, B, C, D. Okay, so this is d, this is minus d. So from here I can have the conclusion that cosine theta is equal to minus cosine 180 minus theta, because this angle is 180 minus theta, and that's what I'm trying to figure out. As you can see, now that we have the unit circle approach, we got out of the right triangle concept and we were able to start calculating the angles that are bigger than 90 degrees. And we already have very important conclusions here, and I think these are enough for this lesson. Important conclusions. Again, sine 0 is 0, cosine 0 is 1, sine 90 is 1, and cosine 90 is 0. For example, even only this one is a very important conclusion. Plus we also have this one, cosine minus theta is equal to cosine theta, and sine minus theta is equal to minus sine theta, for example. I believe understanding the unit circle concept in trigonometry is going to help you visualize the trigonometric functions, especially sine and cosine, easier. The other ones, tangent and cotangent, also have representations of them on unit circle, which we are going to see later. But for now, focus on only sine and cosine. Now you have an idea of the angles that you have never thought before, plus the angles that we even call minus angles. Actually, when you think of angles, what does minus angle mean? It doesn't mean anything, right? How can an angle be minus? There is no physical representation of an angle to be minus. We call it minus just because we chose it to be clockwise. That's why. And it is only historically and traditionally chosen that way. We don't need to think about why. The answer is boring and simple. It's just because we define it that way. In the next lessons, we are going to figure out how unit circle is important for us to solve further mathematical problems. And also, it is, I think, very important for us to understand some concepts that are not possible to figure out only using the right triangles, even though we started defining and understanding trigonometry using right triangles. Let's go to the next lesson and keep learning. Thanks.